Hey, hi all, this is Priyanka Singh. How are you people? Here we are going to discuss a new coding problem which is convert BST to greater tree, where we are given the root of a binary search tree and we need to convert it to a greater tree such that every key of the original binary search tree is changed to the original key plus sum of all keys greater than the original key in BST. As a reminder, a binary search tree is a tree that satisfies these constraints. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of the node contains only nodes with the keys greater than the node's key. Both the left and right subtree must also be binary search tree. So just to brief you out again in the form of diagram, here this is the node. All right, and whatever value we will be having at its left hand side would be always lesser than the value of the node's key. So that is what meant by first line. And in second, whatever values we will be having at the right hand side of the node, that will be always greater than the node's key. Okay, so here 6, 7, 8, 5, all these are greater than 4, and here 0, 1, 2, 3, all those values are lesser than this 4, hence they lie at the left hand side of the node. And this should be true for each and every case, not just for this. If you pick up any set, like for this one, here 6 is the node value and its left hand side value is 5, which is lesser than 6, hence it satisfy a constraint. And another is its RHS, its right hand side 7, which is greater than 6, hence it satisfies the constraints for the binary search tree. Now our target is to change this into greater tree. So how you can see that? So if you observe here, in here or in every binary search tree, you will observe that its tree, rightmost node of the binary tree of this binary search tree would be the greatest element present in this tree, right? So here 8 is the one which is greater, you can say greatest node, the greatest node value. Okay, so what you have to do is, now 8 would be, we are not having any element which is greater than 8, hence 8 will remain as it is. Now its next smaller value is 7. Now I'll add 8 to 7 because 8 is the element which is greater than 7, right? So its summation would become 8 plus 7 would become 15. Hence I will replace this 7 by 15. So that is what they have asked us to do. As you can see here, we need to change the original key plus sum of all keys greater than the original key. Then original key is 7, and the greater value from this original key is 8. Hence adding these two will give us 15 and we will replace this 7 by 15. Now for the next node, next smallest node from this would be 6, right? So as this is a binary search tree, we are at the rightmost node and its parent would be the next smallest value. So when we are when a current node is 6, then in that case its greater values greater than this 6 are 7 and 8, and whose summation is 15, right? Now what we are going to do, we will add this 15 to this 6 current value, which gives us 21, and hence we will replace this 6 by 21. So this is how we are making the solution, by combining smaller solution. Okay, now next smallest value of this 6 is 5. Right, now what I'll do is I'll add this 21 to 5 and assign this 26 to this node, right? And now next smaller value is 4. So this is how it is happening, right? So when we are at 4, I'll add 4 to 26, and which will give us 30, and I'll reassign this 30 to this node. Then next smaller value is 1, Here it is 1. I will add 30 to I'll add 30 to 1, right? Sorry, it's not the 1. Its next smallest value would be the rightmost node present in this particular binary search tree, which is 3, right? So I add 30 to 3, hence we get 33, and I'll reassign this value to this particular node. Now next smaller value is 2. I added 2 to 33, and then we got 35. Next, 1, I added 1 to 35, then I got 36. Then next would be 0. I added 0 to 36, hence we got 36, and we reassigned value to this particular node. So this is how this has been made. So here there are some key pointers that you can observe. One is it would be a recursive solution. If you want to go ahead with a simpler and sober solution, then you can first start with the recursive solution, then you can think of some other optimized solution. So for this video, I'll be discussing recursive so that you can first get the approach to at least first solve this solution. For always, our first target should be to solve this problem, and then you can think of optimizing it in further steps, right? So one is to recursive, all right. And second thing is we need to start with the rightmost node um, present in this tree, right? So how we are going to do that, let's see. um Root is, so we will check until we reach to the rightmost node. Okay. So uh, how we are going to do that? I'll call this recursively. Okay. So here, if we have not reached to the rightmost, that means still we are having something in its right hand side. Then we'll keep on going at its right hand side. And the case when we are exhausted with the right hand side branch of the tree, in that case we will return the node itself, right? So that is what we are doing here. We will check its right hand side, are we having something. If it is not null, then proceed with its right hand side. Still its right hand side is not null, then again proceed with its right hand side. At this point of time we are having its right hand side null, hence I'll return 8 as it is to this 7. Okay. Now, to carry the summation, we have to have a global variable of sum, because this sum would work for all over the tree as globally. Hence, I have kept this globally. And now I'll I'll carry this in the sum. So what I did, I came to this 7, right? And I added this 8 to the summation. Okay. So actually, we were having 8 already, and I added 7 to it. Hence, we got 15. Right? Now, I will reassign the value, okay, with the sum. So, I have assigned 15 to this node. Okay. Now, I will proceed with its left hand side. So once we are done with the right hand side, right? So whatever value, then its next smaller value would be present at the left hand side if it exists. So in this case, it doesn't exist. Then we will move ahead with its parent, right? So this is what happened. It was called from its parent itself. So once this function gets exhausted, then it will move back to its parent. So when we will come to this 6, then it will return 15, right? It will return 15. Now then we will add root value to it. That means we will add 6 to 15, right? In this line we added 15 to 6, and then we got 21, correct? Now 21 is reassigned to the root value. So root value was this. In this node we have reassigned the value 21. Okay, and then we move ahead with the left hand side. And then as we're having left hand side, then we'll cover all these steps again for the left hand side as well. So this is how this is working. So let's check. Okay, this is doing well. Let's submit it and see. Okay, it got accepted. So thank you for watching. Keep 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 up your enthusiasm for coding, and do like, share, and subscribe my channel for new upcoming videos. Thank you.